Hello, hello, and welcome back to CS492F, Futures of the World. Today, we're going to recall, summarize, wrap up, and conclude this course. Let me start by sharing the screen. So this was an experimental course, Education 4.0, where part of the course was provided by you, by the students, by the participants, and part was prepared and provided by me as a lecturer. And the goal was to practice some basic joint, large-scale, and long-term prediction and planning. The joint aspect of this experiment was by having groups together work on individual aspects of futures of the world. Large scale is reflected by various topics that encompass the whole world, and long term is reflected by having an unbounded time horizon, maybe what we called asymptotic futurology. And one goal of this course is to prepare for passing the great filter. Oh, what is again the great filter? The great filter is one possible answer to the Fermi paradox. The Fermi paradox is named after Enrico Fermi, who won the Nobel Prize in Physics in 1938. And at some point he asked, where is everybody? And with everybody, he was referring to intelligent alien life. And indeed, Frank Drake, an astrobiologist and astrophysicist, has set up a formula. Actually, it's a very simple formula if you think about it. An estimate about the number of civilizations in the Milky Way. Milky Way means our own galaxy. As you know, the universe consists of many, many galaxy clusters. Each cluster consists of many galaxies. And our galaxy, the Milky Way, consists of many solar systems. And our solar system is one at the border of our galaxy, the Milky Way. And so the formula to estimate the number of civilizations, intelligent civilizations, N, is the following. So it's a product of several, if you like, probabilities. And the first one, R star, is the average rate of star formation in our galaxy. How many stars are being formed in our galaxy? It's not a static galaxy, but new stars are being born. Next point is, among those stars, how many stars will have planets? Or particularly, how many of the stars that we have been observing so far have been shown to be orbited by planets? And among those planets, how many are in the so-called Goldilocks zone, not too hot, not too cold, not too close, not too far from their orbiting star, their orbiting sun? So per star that has planets. Next, among those planets that can support life, how many of them, which fraction actually does develop life at some point? And among those that does develop life, which ones make it far enough for life to become intelligent? And among those where life becomes intelligent, so these are the called civilization, among those that become intelligent, how many of them become intelligent enough to develop technology to send detectable signals of their existence into space, signals that we would be looking for example, in the SETI project, the Search for Extraterrestrial Intelligence. That's a project that was kind of inspired by Frank Drake. And final, how much time does such a civilization have to send a signal in space once they've managed the technology to do so? Before that, civilization perishes. Some of these quantities are purely physical quantities. For example, the star formation rate in our galaxy is roughly 1 star per year. There's also estimates on what fraction of stars have planets. That's estimated between every second star and every fifth star has planets. Among those that have planets, how many are in the Goldilocks zone? Typical estimate is something like half of the planets, half of the stars have planet in this Goldilocks zone, and so on. And you can continue putting in reasonable estimates. It's something between 10 and 80% for each of these fractions. But the big unknown variable is L, the length of time for which such civilizations release detectable signals into space. Well, for us, we have been sending such a signal into space for like 50 years. That's the Voyager space probes equipped with this golden plate with a recording of human voice. So we've been sending signals for 50 years for now. And if everything goes well, then we might continue doing so for the next 100,000 or maybe 10,000 years. In which case, if that also applies to other civilization, if a civilization has like 10,000 years of sending signals into space, then if you estimate that, there should be many civilizations in space and we should be able to detect that signals. But so far, no such signal has been detected. And one explanation for that is the great filter that civilizations don't make it to the 10,000 years of being able to send signals. Maybe they don't even make it to from 50 to 100 years or 200 years. So that's a great filter. So the concept is that whenever a planet develops a civilization, then that continues evolving from a planetary-based civilization, that's ours currently, to a stellar civilization, to a civilization that can and does travel the solar system where their planet is based. We're starting doing so by exploring the moon, by sending probes onto Mars, by sending Voyager units to Jupiter, and even beyond. And the next step, if one makes it past that stage, is a galactic civilization, a civilization that also travels past the solar system to other stars. Remember that our closest star is Alpha Centauri, that's 4 light years away. So light takes 4 years to get there. But since we haven't been able to detect signals from alien civilization, that's the hypothesis that there's some great filter that prevents civilizations from moving past the planetary stage towards the stellar stage and continue sending such signals. And that's if that such filter exists, then that's an imminent danger also to our civilization. And that's in agreement with what the biologist Edward Wilson pointed out. The real problem with humanity is the following. We have Paleolithic emotions, we have medieval institutions, we have godlike technology, but this is a very dangerous combination, right? Our actions are governed by Stone Age emotions, but we have the power of using godlike technology. That's very disastrous, and indeed, it's currently approaching a point of crisis overall. So that led us to study predictions and guidance towards our positive outcomes of predictions and to avoid negative outcomes of future predictions. And we've reviewed such warnings and predictions, including Greta Thunberg, Sir David Attenborough, Al Gore, and Nick Bostrom. We've looked at predictions and governance suggested by Elinor Ostrom, by Klaus Schwab, by Peter Singer, by Bill Gates. We have looked at some science fiction authors, also an important category of futurologists, like Stanislav Lem, Arthur C. Clarke, Robert Heinlein, and Isaac Asimov. We've looked at physicists and their prediction, including Freeman Dyson, Carl Sagan, and Isaac Arthur. And our goal was to practice long-term, joint, big-scale predictions, namely asymptotic futurology, noticing that some things simply cannot be predicted because they are too volatile, too sensitive, but other things can be predicted, things that will happen eventually, inevitably, like we throw a marble into this golden board. We cannot really predict where it will land. We can assign probabilities to where it lands, but not predict. But one thing is for sure, it will end up at the bottom. So this is something that can easily be predicted. And so we don't aim to predict when it happens or how it happens. And this corresponds to what Elon Musk called first principles. And some example that we considered as motivation is the connection of South Korea to a neighboring island and country. So what already exists is power cables connecting Korean mainland to Jeju Island. One was created in 1998, another one in 2013, and a third one has been completed maybe this year. So these are all roughly 100 lengths under the ocean power grid cables. So the next step, and that's an example of asymptotic futurology. We don't know when, but it's inevitable that there will be a power cable that connects Korea with Japan. And technologically, this is not so far-fetched, because to Tsushima Island, it's only 50 kilometers, half the distance to Jeju. And from there, it's roughly 140 to 150 kilometers on to Fukuoka. So that's only like 40 or 50% longer than the existing cable to Jeju. And it will have tremendous benefits being able to share and balance both electrical power production and electrical power consumption to balance it together with a neighboring country. And after that, even further into the future, but equally inevitable, is land connection a tunnel, a bridge combination to enable traveling, for example, by train or by car from Korea to Japan. When I was in elementary school, there were similar predictions that there could be a tunnel between Europe and United Kingdom. And indeed, nowadays we have this Eurotunnel. So this is an example of a prediction. And we approach these predictions using flipped learning, education 4.0, with 8 topics. Topic A, future of occupation and economics. Topic B, future of geopolitics and governance. Topic C, future of ecology and sustenance. Topic D, future of transportation and travel. Topic E, future of societies and value belief systems. Topic F, future of education and entertainment. And topic G, future of health and medicine. That's 7 topics, not 8. The first topic, A, future of economics and education, was prepared and presented by Damir, by Ji-Huan, and by Ensu. Second topic, future of geopolitics and governance, was presented by Donghyun, by Yeon-woo, and by Taehyun. Topic C, future of ecology and sustenance, was presented by Amen, by Dildas, and by Jimin. Topic D, future of transportation and travel, was prepared and presented by Dongkyu, by Junho, and by Min Song. Topic E, future of societies and value belief system, was presented by Hallelujah, by Nur Sultan, and by Dongwon. Topic F, future of education and entertainment, was prepared and presented by Eugene, by Won Sung, by Donghyun, and by Gina. And finally, topic G, future of health and medicine, was prepared by Dongyu, by Yunho, by Philip, and by Haram. So let's now take a short break and look at some other predictions. And specifically, what I'd like to show you is the prediction made by an artificial intelligence, which is kind of paradoxical, but that's the fun of it. So let me show you this prediction.
Designing 400 years into the future, 2 Arcadians set out on a mission to both warn humanity of the dangers of the current climate conditions and show our species its great potential should we work together. And so we begin, known to the Arcadians as the Reckoning, in the year 2040, where society's efforts to push initiatives and agendas of sustainability failed due to humanity's obsession with over-consumerism. Next, we have the dystopian era, taking place in the year 2070, where the living conditions are inconceivably depressing, unhygienic, and inhumane. Also, with the sheer mismanagement of waste dumping around our beloved planet in space, leading world governments to assemble the people of the nations. After much trial and tribulation, we move on to the year 2100, the Retreat, devised as a plan for the rest and recovery of our natural world. In the year 2100, humanity looks to live away from the surface for 50 years. And so a new chapter begins with the return, the year 2200. And upon returning to the surface, humanity finds that the plan to allow nature to once again flourish worked outstandingly, with all the greatest scientists, pioneers, futurists, and imagineers devising methods of evolving the current society's technology and architecture around transbotanism, and with efforts of prosperity humanity begins rebuilding with nature in the year 2250. The Imagineers and visionaries of today in 2250 use biomimetic 4D printing in order to grow architecture, all from natural matter, artificially reproduced and edited for our needs, and once again assemble harmonious routine life into local neighborhoods. And just when our technological development peaked as we thought, in comes the new frontier of what we consider to be the nature of life itself. We've finally done it. The singularity is here. Humans have merged with AI and uploaded themselves to the digital realm, leaving behind all manners of physicality, therefore solidifying our position as a Type 1 civilization with our eyes fixated on the next challenge. Brought to you by Arcadia Foundry's design team. Thank you for watching.
Next, let's talk about the ethics of futurology. What if you're able to predict the future accurately? What are you going to do with that? So this is about the ethics of futurology. What if you're able, for example, to predict the change of the stock market? What would you do with that? And this is where the dilemmas start to come in, because when you're able to predict the behavior of the stock market, then you will invest maybe you will invest according to your predictions, but this investment will in turn change the course of the stock market, right? So this is an example of a self-fulfilling prophecy, right? So your actions towards others impact others' beliefs and therefore others' actions, and that in turn affects our beliefs and our actions. So that's an example of a self-fulfilling prophecy cycle. And you know, there's laws about insider information about stock market that try to prevent people from illegally using, that makes it illegal to use the ability to make such predictions, right? On the other hand, there's also the opposite, self-defeating prophecy, when you warn people against something, like, for example, climate change, then hopefully people will start to take actions that prevent climate change. And in the end, arguably, there will not happen any climate change, so that your prediction, your warning will be considered in vain, will be considered wrong, but actually it was the prediction that prevented and avoided climate change. So these are two aspects of futurology: self-fulfilling and self-repeating prophecy, and the ethics that come with it, or as this movie hero said, with great power, like power of prediction, comes great responsibility. One question, for example, is, if you manage to make a prediction, who do you share your prediction with? Do you share it with only with your closest relatives and friends, so that they can harness, for example, stock market prediction? Or do you keep it to yourself, so that only you benefit from it? Or do you make it entirely public, or somewhere in between? So that's all very delicate ethics, and I'd like to show another movie depiction of that. So here's the movie Minority Report that deals with exactly such questions.
Okay, Jan, what's coming?
Double homicide, one male, one female. Killer's male, white, 40s.
Set up a perimeter and tell them we're en route.
I'm placing you under arrest for the future murder of Sarah Marks.
Give the man his hat.
The future can be seen.
All we have to run on are the images that they produce.
We see what they see.
There hasn't been a murder in 6 years. There's nothing wrong with the system. It is perfect. I agree.
Murder can be stopped.
Tell me exactly what it is you're looking for.
Flaws.
You ever get any false positives? We are arresting individuals who have broken no law.
But they will.
The fact that you prevented it from happening doesn't change the fact that it was going to happen.
The system can't be wrong.
You say something, Chief?
No.
You're in a lot of trouble, John. I have a warrant in my pocket that says murder.
Don't run.
You don't have to chase me.
From 20th Century Fox
He set me up. He set me up.
and DreamWorks Pictures.
Who's the victim? I've never heard of him, but I'm supposed to kill him in less than 36 hours.
He's coming here to get her.
Tom Cruise
I need your help. If you contain information, I need to know how to get at it.
in a Steven Spielberg film.
I have to know. I have to find out what happened in my life. You tell me, who was it that set this up?
I don't know.
How about now?
On June 21st, everybody runs.
No, it's hard.
Minority Report.
Yes, so this is exactly about self-defeating prophecy, predicting when a crime will happen and preemptively arresting the perpetrator, thus preventing the crime, and the moral, the ethical question, the dilemma that come with such predictions, and betrayal, and that's a topic of this movie. So now we're approaching the end of today's session. So I want to close by thanking you, the participants, for your highly original visions and predictions. I was really impressed by the degree, the depth, and of your visions. You made a great balance between presenting your own conceptions and including external reports like videos. You pointed out both optimism, optimistic futures, and caveats, things that we want to avoid in future development. You gave very solid and understandable, accessible talks and presentations. So thank you for contributing, for joining this Experimental Education 4.0 project. I also want to thank the TA, Abbas Mamadov, for tracing, for example, attendance, and for keeping track in this course. And now we've reached the end of today's concluding session. And this is the time to have some discussion and also some feedback. As you know, you are asked to evaluate this lecture. You're asked to evaluate me, and I appreciate your feedback, both positive and negative, constructive or not. So feel free to discuss this now. So that's the end. And also please remember to review the recordings on YouTube that we made. If you want to cut out something, or if you want to add subtitles, that's all highly welcome. So please remember to review this. So that's the end on my behalf, and now we can join the discussion.